Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to apply the ideal gas equation to a gas problem. Okay, so here the first I want to talk about when to use the ideal gas law. So to use the ideal gas law, you want to look at the problem and see if there is a change going on in some property of the gas. So is it changing temperature? Is it changing pressure? Is there a change in volume, the amount, something like that? If you see that there's a change in some characteristic of the gas, then odds are you're not going to be using the ideal gas law equation for that. You're going to be using some other equation like Boyle's law, Charles' law, the combined gas law, Dalton's law, or whatever the law may be, but it's not going to be the ideal gas equation. Okay. But if they're giving you a list or the characteristics or values given for each characteristic of a particular gas, and they want you to find this other characteristic, like maybe they give you the pressure, the volume, and the amount, and they want you to find the temperature, right, of the gas, or maybe they give you the temperature, volume, and the pressure, and then maybe they want you to find the amount of the gas. If that's the case, then you're going to use the ideal gas law equation to solve the problem. So let's go ahead and look at this problem here. Here we have at what temperature will 0.0421 grams of argon in a 23.0 milliliter incandescent light bulb have a pressure of 95 millimeters of mercury? So here they're giving us the amount of the gas in grams. They're giving us the volume of the gas in the light bulb. They're giving us the pressure of the gas, and they want to know the temperature of that gas. So here, there's no change in anything. There's no change in pressure. There's no change in volume or anything like that. So here, we would use the ideal gas equation. So first thing we want to do is list the information that they're giving us, so that way we know what's missing and what we need to convert if necessary. So first, they're giving us the mass of the argon gas in grams. So here they're giving us M. I'll have M as in mass. Mass is 0.0421, and that's grams of argon. And they're giving us the volume of the light bulb. So the thing about gases, remember, is that they have the volume of whatever container they have. So in this case, the gas is in the light bulb. So if the light bulb is 23.0 milliliters, then that's the volume of the gas. So here, the volume of the gas is 23.0 milliliters. And they're giving us the pressure, and the pressure is 952. Oops, I should write the letter down. So P for pressure. So pressure is equal to 952 millimeters of mercury. Okay, now there's a couple of ways to go about this. I'm going to show you one way, and then I'm going to show you another way. So the first way is to use your normal regular, I can't think of the word I want to use, ideal gas equation. The PV equals nRT. So PV equals nRT. Right. So I'll show you a different form of the equation that you could use for a problem like this. But we're going to use that one. Lights went off again. Okay. So we're going to, in order to use this, we need to convert our units to the proper units. We're trying to find temperature, so that'll be in Kelvin when we solve. But this is all going to depend on our R value, right? So if our R value has certain units in it, then we need to make sure that these units that we have fit with those units in the R value. Now the R value, it'll just depend on what R value you use. The one I'm going to use is going to be the 0.082058, or you might know it as 0.08206 or 21 or whatever. That's the one I'm going to use. That one has the units of atmospheres, liters, moles, and Kelvin. So we got to convert these to their proper units. So the mass is going to be needed to turn into moles. So I'm going to use the molar mass of argon. So here we have 0.0421 grams of argon. And I'm going to use the molar mass of argon. So on the periodic table, argon has 3935. So 39.35, let me double check that again. 3995. 3995 grams of argon per 1 mole of argon. Okay, so now let me double check it once more. Okay, so the grams are going to cancel out, and now I have moles. So if I calculate the number of moles, I get 0.001058. So 0.001058, and that's moles of argon. So now I've got the moles. I need milliliters and liters, so I'm going to convert that to liters. So 23.0 milliliters over 1 milliliter. Since milli is the prefix, the multiplier is 0.001 or 10 to the negative 3 or 1/1000th of a liter. So that's going to be 10 to the negative 3 liters. And then milliliters cancels out, and I get the volume in liters is going to be 0.0230 liters. And then I need to convert this to atmospheres, because that's what the unit is in pressure in my R value, in my ideal gas law constant. So I'm going to take the 952 milliliters of mercury, and I know that 760 millimeters of mercury is equal to 1 atmosphere of mercury. So millimeters of mercury, oops, I forgot the G. Millimeters of mercury cancels out, and then I calculate the answer, and I get 1.25263. 1.25263 atmospheres, right? And now for the sig figs here, I should underline or figure out where my sig figs end. So here I have 3 sig figs, and here I have 4, so 3 is the least. So 1, 2, 3, so here 5 is the last one. And then here I have 3 sig figs. This is exact, so I ignore that. So I'm going to have 3 sig figs, so it ends there. And then here I have 3 sig figs. This is exact. So this should be 3 sig figs, 1, 2, and 3. So it ends there. I'm going to keep the other digits for further calculations so that I avoid a rounding mistake. You really only need to keep 1 extra digit. I'm keeping a couple more. If you just want to keep 1, that's fine. But you should keep 1 extra digit if you're using the value for any further calculations. If you're done here, then yeah, you could get rid of the 3.8. But if you're going to use that number to do further calculation, then keep at least 1 extra digit. Okay, I got everything ready. I'm going to plug everything into my equation. Now, the equation is PV equals nRT. I need to solve for T. So PV equals nRT. I want T by itself, so I'm going to divide everything by N and R. So both sides divided by N and R. So these cancel out. So I get T is equal to PV over NR. Okay, so now I can plug everything in. So here, the pressure in atmospheres is 1.25263 atmospheres. And I'm going to put a line under the 5 so I remember. And then I'm going to multiply that by the volume, which is this right here. So 0.0230 liters. And then I'm going to divide by N. N, we got here 0.00. Okay, so 0.001053. I'm going to put a line here. I'm going to put a line there and a line there. And this is going to be moles. And the R value, as I said, we're going to be using 0.082058, and that's going to be liter atmospheres over Kelvin mole. All right, so now we can cancel out the units. So atmospheres on top cancels out with atmospheres on the bottom. Liters on top cancels out with liters on the bottom. Moles cancels out with moles on the bottom. And so we're left with K. So here, Kelvin, which is great. So now if we calculate this, we'll get a temperature of 333 Kelvin. 333 Kelvin. And the reason it's 333 Kelvin is because the sig figs here, when we multiply and divide, remember the answer should be that my answer should have the same number of sig figs as the measurement with the least number of sig figs, right? So here I have 1, 2, 3, stop at the 5. Here I have 1, 2, 3, stop at the 0. 1, 2, 3, stop at the 5. And here I got 1, 2, 3, 4, 5. So the least number is 3. So that's why I have 3 sig figs. Now, if I subtract, I can change this to degrees Celsius. If I subtract out 273, right, rounded, right, 273.15 rounded, 273, and then that'll become 60 degrees Celsius. So either one of those is fine. And here you can see that it's not 2 sig figs anymore. The reason is because, remember, when you're talking about the rule of rounding with regard to subtraction and addition, when you subtract 273 from this, the issue or the concern is that your answer should have the same number of decimal places as the least number of decimal places in the measurements that you're adding and subtracting. So here it's not about sig figs, it's about decimal places. So this has 0 decimal places. The last digit is the ones place. Here the last digit is the ones place. So here the last digit is the ones place. So that's all we care about here. Okay. All right, so that's it for this video. I hope that you enjoyed this video. If this was helpful in any way, then please, by all means, like the video, share the video, hit that like button. Also, subscribe to my channel, please. Let me know what you think. Also, when you do subscribe to the channel, make sure you hit the notification bell. And when you do that, make sure you click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Also, if you have a problem or a question you want me to go over for you, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me and have a great day.